Hello, everybody. Today, I will present you a quite challenging presentation. Sunscreen is a quite hot topic. We make the headline every year, and today I will try to explain you why. What are the causes of that? But please remember that the goal today of my presentation is not to say who is right or wrong, but to give you some food for thought. So that's the question. Is it true that the SPF claim by the brand are not always the SPF measure? You have here some example. So probably yes, but you will see only from time to time. So before to explain what could be the causes of that, I would like to see what could be the cause. The first cause could be the measurement. Is it the method who are good or bad? Or is it due to the industrial, or is it due to the consumer? Before to looking at the first hypothesis, let's take a look at the method of calculating the SPF, just to remind you for some of you. So the SPF, the definition is the ratio between the MEDs and the minimal erythemal dose on the protected skin divided by the minimum erythemal dose on the unprotected skin. Let's have an example. You can see here on the screen on the left hand, the minimal erythemal dose on the unprotected skin. So imagine that the minimum erythemal dose is 3 joule per square centimeter on the unprotected skin and 45 on the protected skin. So, sorry, it's not 3, it's 2.68. So if you divide 45 by 2.68, this will give you the in vivo SPF, then 17.79. That's the calculation of the SPF in vivo. Remember also that the application rate is 2 milligrams per square centimeter. This is really important because I will come back to this later on. It's not really an easy task because this is also an example. We have to read the MEDs and the erythema. So it's not so easy to read, and the mistake is quite easy to do. So you have here an example of what we have to read. Of course, it's a photo. And in live it's much better, but it is quite easy to make an error here. Another point that I would like to remind is that remember that the SPF in vivo is made at 2 milligrams per square centimeter, and it is quite well known now that the consumer don't use 2 milligrams per square centimeter, but in application thickness around 0.5 for the minimum and 1.5 for the maximum, with a mean around 1. It's more about 0.8 to 1 milligram per square centimeter. Then we are very far away from this famous 2 milligram per square centimeter. So the question is, why do we use 2 milligram per square centimeter in the referenced method? It is quite easy to answer to this question because the most important things when you want to develop or validate a method is to be reproducible and repeatable. And this method is only reproducible and repeatable at 2 milligrams per square centimeter. And of course, we know that before to validate this method, but below 2 milligram per square centimeter, this method is not reproducible and repeatable. So we cannot claim that the SPF indicated on the product will be the real SPF that each individual have for all conditions. And this also is very important. Then what could be the definition, the real definition of the SPF? Is not really the MED on unprotected divided by the MED unprotected. This is the technical or the mathematical definition. But what is the definition, if you want, of the SPF if you want to explain it to someone? I think the best one is that the SPF is a relative ranking scale of effectiveness against erythema, which serves as a benchmark for consumer choice. It's just a relative scale, no more. Because if I want to ask you, you can see here 3 different ladies, pale skin, medium, and I will say more darker skin. Which SPF shall I use or shall I propose to this lady? Is it SPF 50 for the pale skin, SPF 15 for the darker one, or SPF 15 for the light and 30 for the brown, or SPF 30 for everyone? I'm quite sure that if I ask you this quiz, most of the people will say, oh, of course, it's the answer is A, SPF 50 for the light skin, 30 for the medium, and 15 for the darker skin. But I can tell you the real answer is A, B, or C. I cannot tell you which SPF shall I propose to this lady. Why? Because to know exactly the SPF that I should propose, I should know, of course, the phototype, but not only the phototype. I should also know how you spread the product onto your skin. Where are you going? The location, the altitude, the latitude, but also the weather. Is it very blue sky or is there some cloud? Also the environment. Do you go to the beach with white sand or with a black sand close to the water or on the grass? And lastly, the quantity. And of course, the quantity is also very important. If I know all these parameters, and you see there are a lot of parameters, yes, I can tell you which SPF you can use. But without that, I cannot tell you this. So to try to explain you, probably you know this car, it's Peugeot car, and you know that there are different category. You have the 108, 208, 308, 508. If I ask you how you choose this car, do you choose a 308 because the 308 go 3 times faster than the 108? I'm sure no. You will choose it because you have a family, or you choose a 108 because you want to drive in the city, but not because it goes 3 times faster. Then this number is a relative scale. Exactly the same for the SPF. The SPF is a relative scale against erythema. If you choose an SPF 30, it's because it protects you more than an SPF 10, but not 3 times more. In life, I will say on the beach, not in institute. Of course, in institute it is the case. So to come back to this question, is the method not enough repeatable? No, the SPF in vivo is repeatable, and it is a really good method. The ISO 24444 now is validated by ISOs and with a big group of experts, is repeatable and reproducible. But with a huge, with a degree of uncertainty. like any method done on human volunteers. Then it is reproducible and repeatable, but of course with a kind of uncertainty. So the second cause could be, is it due to the industrial bullshit? I cannot say that it is impossible. But the method that we use is normalized, and this is an example of one of our brand. The SPF is, as I told you, measured by an ISO method, the ISO 24444. The UVA, at least in Europe, could be measured by another in vivo method, the 24442 or the 24443. And sorry, I make a mistake here. I not change. The water resistance now is challenging by another ISO method. Then it's not running. You can claim the water resistance also thanks to an ISO method. So yes, it's possible that time to time industry can make an error, but it is most of the time the result is very good and is linked to the claim. So if we see some problem between claim and SPF measure, the other cause is perhaps the consumer pressure. A consumer pressure to have higher and higher SPF. It is quite easy to find, probably not in Europe, but elsewhere, SPF 70, SPF 90, 100, and even I find it on internet, SPF 150, always higher. And do you really think that an SPF, forget SPF 100 or 150, and let's focus on what's happened in Europe? Can you really believe that it is possible to have an SPF 50, 50 plus with less UV filter, less active ingredients, reef safe, organic range, non-nano, but transparent, non-oily, non-sticky, etc. Cheap, of course, not very expensive, and following the international or national regulation. Do you really think it's possible? Of course, this is for now. Perhaps we will have more problems later on. Do you really think it's possible? Let's see what's happened today. You know that in Hawaii, they will ban 2 UV filter, OMC and benzophenone 3, due to the harmful effect on coral. I don't want to enter in this polemic today, and this is not the aim of this presentation, but I really, I would like to propose you to look at this very, very interesting paper from Carrie Mitchell-Moore. For me, is one of the best experts on this topic. And this is the very last publication that she published. It's a critical review, then very interesting. And this is a conclusion that there is currently limited evidence to suggest that corals are adversely impacted by environmental exposure to UV filter. Very interesting to keep that in mind. Anyway, we have the pressure. So you have seen that due to Hawaii and some other island, we cannot, it's difficult to use OMC and benzophenone 3. But if you go to internet, you can see many different ONG or different health organizations saying that please avoid, for example, oxybenzone, oxynoxate, octocrylene, omosalate, and so on. Here you have other example on this one. Then if you add all the NGO and all the Earth organization, all the different local law, you can see that you can only more or less formulate the UV your sunscreen with 1, 2, 3, perhaps 4 different UV filter. And I can tell you that formulating with 4 UV filter is quite impossible to reach an SPF 50 or 50 plus. You know that if you have a yield of UV filter and SPF above 2, it seems unlikely to me. And above 3, it's extremely unlikely. An example, if you have 10% of UV filter, it seems to be very, very difficult to reach SPF 20. I don't want to speak about SPF 30. So what are we serving? This comes from a presentation of Paul Matz. Is a good question. Who are we serving? But I think the answer is consumer health. And if you look at the different papers that you can see and read, actually, it's quite clear that the incidence of cancer continue to rise all over the world, in Europe, but also in other countries. And I feel that I have a duty to offer a consumer an effective means of protection against the effect of sun in order to protect their health. Then we have a responsibility here. So this is other example of the rise of the cancer. So if you remember that the SPF is a relative scale of effectiveness, but also that the maximal accumulated exposure to ultraviolet rays at latitude 30 at sea level is about 25 MED per day. If you keep that in mind, but also that the SPF in vivo efficacy is not only due to the spectral absorbance of the product. In fact, the quantity, the percentage of UV filter, but also to the uniformity of the application and to the quantity applied. And have a look. The percentage of UV filter is only around 8%. The weight is only around 8%. That means that the SPF, the efficacy, the impact on the SPF is mainly due to the quantity applied and the uniformity of the application. So what does that mean? If you apply crudely an SPF 15, you have 44% of chance of risk to have an erythema, a marked erythema. If you use an SPF 30, the risk is lower, 26%. If this time you spread carefully your product, an SPF 15, you have only 4%. The risk is only 4% and 0.1% with an SPF 30. What is the conclusion of that? Of course, both crude and careful spreading, it's always better to use an SPF 30 than SPF 15 to avoid sunburn. Of course, it's quite obvious. But what is the other message? Quite interesting. Look at this. It's much better to use carefully or to carefully apply an SPF 15 than crudely apply an SPF 30 to avoid sunburn. 4% if you carefully spread your SPF 15, 26% of risk to have an erythema with an SPF 30. So, what is the best way to apply your product and what is the best amount to apply. In fact, it's you who must choose, and for that, you have to choose the SPF that you like, not because it's an SPF 50 or 50 plus, because someone tell you to use an oil or to use something else. No, you have to choose the products that you like. And remember that the SPF, it's only a relative scale. Then what is really important is to use a high quantity of product and to spread it carefully onto your body. So this, I would like to quote a sentence of Hillary Clinton saying the same thing for the vaccine, but the science is clear. The earth is round, the sky is blue, and the sun scares works. Yes, of course, time to time, you can find an SPF, a claim SPF, not linked with the SPF that you can find with a report and with the institute. Then it can happen. But most of the time, the SPF claim and the SPF that you can find with an institute will be very close to what you are claiming. And yes, the science is clear. Sunscreen works because you can find on also many different publications saying that please use sunscreen because the risk of melanoma, of cancer, of skin aging decrease if you use the SPF. The sunscreen, sorry. So to conclude, I think there's nothing wrong to present extreme scenario to stimulate the research, but please, this doesn't reflect the reality, and that doesn't justify the media headline. The second point is that do we have to minimize? I have made a very only one or two words on that, but yes, all the major brands want to minimize the environmental impact, but please, this should not compromise the protection of human health. If we continue to decrease the number of UV filters that we can use, we will compromise our human health because it will be quite impossible to reach an SPF 30, 50 or more. So the only concern that you should have about the sunscreen is, did you remember to put it on? So please remember that for the next summer, we are very close now to the summer, then please remember to put it on. Thank you. Then if you have any question, I will be happy to answer to it.
Wonderful. Thank you so much, Mark, for that fascinating presentation there and really good advice at the end. In answer to your poll question, I would have probably answered SPF 50 for the Nordic looking lady there. So you are absolutely correct. That would have been my assumption. So from my point of view, I was wondering, considering that better application is needed by consumers in real life, if we can't readjust the 2 milligrams per square centimeter due to something more realistic due to this reproducibility, what ways can brands really encourage their consumers to put on the right amount of sunscreen to take the time to apply it properly? What are the best ways of doing that?
It's not, it's like drug. You remember when, if you have to take medicine, you dislike the test, you will take a very low amount of this drug, and it's exactly the same for cosmetic. It's for that I have said that I will say, dangerous or risky to say that you have to choose this product because this product is the best one. But if you don't like the smell, if you don't like the galenic, why a brand propose so much galenic? You have oil, you have milk, you have spray, you have mist, you have many different galenic. Why do we do that? Is to offer you the possibility to choose the product that you like. And again, I encourage you not to choose the product because your sister or your, I don't know, someone say to you, this is the best one. No, you have to choose the product that you like. And if you like the product, that means that you will spread it and you will use more product. Is instinctive. If you like it, you will use more.
Fantastic. And you were talking then about segmentation by galenic. However, earlier on, when you were saying about things like altitude, location, weather of when you would be using the product, I was thinking, could the sunscreen industry do more to segment in terms of activity or location when it comes to claim?
Yeah, sure. For example, when if it is a BH product, it's water resistant. You need less water resistancy if it is product for skiing to use on mountain. It could be sweat resistant if you use it for sports. So yes, we have different claim and different galenic due to the activity what you that you want. We have also product for child, for face. Then yes, we have different galenic.
And I know you didn't necessarily want to go into much depth about, obviously, reef safe, but is there a danger that, for example, these NGO recommended filter lists being so huge that eventually there's going to be some sort of cottage industry with well-meaning brands creating products which really don't do what they should do, and that's so dangerous with regards to sun care?
Yes, exactly. It's what I tried to explain during my presentation. If you will always find one NGO saying that, oh, this one is bad. But if you sum up everything is bad. And I'm not big expert of toxicology, of marine toxicology, but I know by experience and by reading some information that marine environment is so um, how can I say that? If you add salt in water, in seawater, if you change, all the coral will die because they are so sensible. I look for this. They are so sensible to the pH, to the salinity, to the temperature, to everything. Then of course, if you make experiences with some sunscreen, of course you can see damage on coral. But what's really happened in live, I say in the ocean, not in laboratory. It's for that I put the very interesting paper of Carrie Michel-Moe, because she makes her experiment, and this review is not made in laboratory but in a real life, and she have seen that most of the study made actually is made in milligram per liter, and in real life you see in nanogram per liter. Then the range is huge. Then due to the pressure to this all NGO, yes, it could be dangerous, because one of these days we will have nothing. And even if they propose to use titanium dioxide, I'm sure that in 1 or 2 years, you already can find some publication saying that also titanium dioxide is harmful for marine environment. But we have to weigh that. We have to weigh the danger. Everything is dangerous. Water is dangerous. everything is dangerous. Salt is dangerous. And risk. And what is the risk for the coral? And what is the benefits risk between the, that's my opinion, the small risk to make adverse effect on the marine environment and the big risk to have a skin cancer.
Very wise words there. Thank you so much for joining us. Unfortunately, that's all we have time for. But thank you, Mark, for a really interesting presentation and some insightful Q&As there. Thank you.
Thank you.